Okay, so today we will be discussing about the energy in the electromagnetic field, and this will be in fact given in terms of the Poynting vector, and we will also be able to get what is known as the Poynting theorem. So these are the equations, the four Maxwell's equation. We have del dot D 4 pi rho, which is for the media. The second equation, the curl of E. The third equation, the del dot B and del cross H equation. D and H are defined as always. They used to be. So now what I will do, I will take these two equations, 1.2 and 1.4, and try to write the value of del B by del T from this equation and del D by del T from the 1.4. Okay, so taking 1.2 and 1.4, what we could write, we write 1 over C del B by del T. So this is going to be minus del cross E. And let's see this one. So this is going to give you 1 over C del D by del T. So this is going to give del cross H minus 1 over minus 4 pi by C, the J. So now what I will do, I will multiply the first equation by H. So this is 2. So 2.1 into H and then dot it plus 2.2, then E dot it. That means we will be taking the gradient. So what happens? We will get 1 over C del over del T H dot del B del T plus E dot del D del T. And in the right hand side, we should be able to get minus H dot del cross E plus E dot del cross H minus 4 pi by C J. In fact, this is going to be E dot J. So now this is what? This is just the dial of the divergence of E cross H. And here, if we write H as B by mu and D as epsilon E, and then it is going to be B dot del B by del T, which is nothing but half of del by del T of B square. So or this is going to be del over del T of. So this is going to be B square by mu plus this is going to be E dot E. So this is E square epsilon E square. And of course we will have a factor of 2 because the derivative would be 2 times B. So therefore this should be 2. And this whole thing could be written as minus of Poynting vector. So this whole thing is going to be minus of divergence of E cross H, and this is going to be minus 4 pi by C E dot J. Now if we define some vector as C by 4 pi E cross H, okay, so this is 3 and this is equation number 4. 3 becomes 3 could be rewritten as, so this will be 1 over 2c. This is del T, and what is this thing? This is nothing but the energy density. Okay, so this is del J by del T, and this is going to be minus, so this is del cross H, E cross S, so this is 4 pi by C S, and then we will have minus 4 pi by C E dot J, or in the next step this will become, this should be del dot S, so this will become del xi by del T plus 2 4 j 8 pi by C. So this is 1 over 8 pi in fact if we wish to write. So let's divide by 4 pi by C, that would be better so that we could cancel these things. So this is going to be 1 over 8 pi del xi by del T gradient of S plus E dot J. So that should be 0. So this S is called the Poynting vector. So this is equation number 5. S is called Poynting vector. And 5 is called Poynting theorem. Now let's see what we learn out of this. See, this looks like somewhat equal to the equation of continuity. Xi, remember what was xi? Xi is energy density. What way it's moving? It is moving along the direction of S. Okay, so this is something like del rho by del T plus del dot J. Okay, so in the absence of source, J is going to be 0, and therefore what we will get is 1 over 8 pi del xi by del T plus del dot S. This should be equal to 0. So this resembles del rho by del T, the equation of continuity, gradient of J, that should be 0. Okay, so what it means that this energy is also getting conserved. Now what are these energies that would be discussed in the next lecture? What we will realize, one of them is the electromagnetic energy and the other is translated as the matter energy. Okay, so the two energies are going to be balanced. However, let us write the integral form of the Poynting theorem. Okay, so if we integrating over the whole volume, what we will get 1 over 8 pi, and then this is going to be d by dt. Write it over here. So this is going to be d by dt of integration 1 over 8 pi, and then we will have epsilon square as we had written before, and then b square by mu d volume plus E dot J dV and plus gradient of S dV, that should be 0, or in the next step this is going to be d by dt. So this is going to be d, the electromagnetic by dt, okay, and that's going to be plus, what is this? If we use the Gauss's theorem, this could be written as the S dot n hat d, the area, okay. So this should be equal to E dot J dV, or E dot J, the V is going to be what? Now let's check what this is going to be. Now E dot J dV. So this is going to be E, and what is J dV? J dV is nothing but the current, which is Q times the V. So this is E. What is E? So this is E and then dot Q V, the velocity. So this means we could write Q E dot V, or we could also write E plus. So because this is V dotted with something, so if we take a scalar product like this, okay, so you could check that this is fine. We will still have the only this term surviving because this is going to be a scalar product having two identical vectors which are V's. So and now we know what this quantity is. This is the electromagnetic force. So electromagnetic force times the V is this quantity. That's how it could be interpreted. Now force times the velocity. Force times velocity is nothing but the power. So which is dW by dt. So that's how you could interpret. So this is the work done per unit time, or essentially the power. Okay. So this is the power, and therefore we could write this equation as du electromagnetic by dt plus sort of dW by is equal to dW by dt plus S dot n hat dA. So looks like this is going to, so here is the electromagnetic density that is kind of doing some work in certain time, and other than that this is sort of creating some pressure along the area normal to the direction. So this is sort of T dot dA, which is later interpreted as the stress energy tensor or the Maxwell stress tensor. That would be covered in the next lecture. Thanks.